working. So yeah, very big welcome to everybody. Nice to have you with us again. For those of you that are joining for the first time, my name's Lee. I'm the teacher, and the beautiful Coco, my friend, is my sidekick and a teaching assistant. So please, we love it when you interact with us. Please ask us as many questions as you want to. We really don't mind explaining things over a couple of times for you to be able to understand it. That's what's most important to us. Yeah, and of course we want you to interact with us. So if you want to unmute your mic and ask a question, you're very welcome. Or if you want to pop something into the chat, that's also no problem. We'll endeavor to get around to everybody and try and answer all of your questions. All right, so the last time that we were together, which was Thursday last week, we were discussing similarity in triangles, all right? And today we kind of need to expand on that idea. And what we're going to do today is going to be a little bit more difficult. It's not problem solving, but it does sort of feature on the end of being sort of a little bit more difficult. Because the big difference between the example that you see on the screen in front of you now, example number 10, as opposed to something that we were talking about on Tuesday or Thursday, does anybody know what the big difference is? Can anyone tell me before I tell you what the big difference is? Why is this a bit more?
Surrounding the triangles.
Okay, that does make it a little bit more complex. Fine, Jamie. Fair enough. I mean, that's true, but it's not what I was asking exactly, but that's a good answer. How would you prove that BC over AC equals AB over AD? Where does that come from? Tangents are involved. Fine, that does make it a little bit more tricky. The minute they use the word tangent, of course, we have to start thinking about all our grade 11 theorems that involve the word tangent, but we'll get to that now. What I'm trying to get at here, Matrix, and I know, like, if you haven't done this before, it's not obvious, okay? So if you don't know what I'm talking about, I can completely appreciate that. They have not told us which triangles to prove are similar. So they've told us to prove a particular ratio, but they haven't told us in which triangles to work. This can't be proportionality intercept theorem, right? Because there are no parallel lines.
Parallel lines.
Exactly, Tobile. There's no parallel lines. So we have to be working with similarity. We have to be, okay? But the problem is that we don't know in which triangles we are supposed to be working, right? Now, to make things even more complicated, you are not allowed to write this down on the page. This over here, this is what you're trying to prove. So if you come along as a student and you write A and you go, okay, so BC over AC equals AB over AD. Yes, okay, and then you start whatever working out over here. It's going to be marked as completely wrong because this is what you are trying to prove. You cannot make this as a statement in the beginning. All right, so if you now want to do a little bit of rough work to decide which triangles we're working in, you've actually got to put a little, well, not a note, but you've got to put a little thing on the side and you've got to say rough work. And then you can put a line through it afterwards so that it doesn't get marked. Okay, you are not allowed to write BC over AC equals AB over AD. That is what we are trying to prove. So now we've decided it's not a proportionality intercept theorem. We have to prove that triangles are similar, but which triangles? Okay, so the way that we do this is like this. The first thing that we want to do is go side to side. Okay, so we ask ourselves, is ABC a triangle? Now look at the diagram. Is ABC a triangle?
Yes, ma'am.
Yes, it is. Okay, cool. And then we must go side to side at the bottom. Is ACD a triangle? Is ACD a triangle?
Yes, ma'am.
Is it?
No, it's not.
No, it's not. Okay, ACD, there's no line going across here. Okay, so ACD is not a triangle. All right, so now that means we've got to try something else. Okay, so side to side didn't work. All right, so now what we do is we go around the outside. Okay, so now I'm going to do this. Is ABD a triangle?
Yes, ma'am.
It is. Okay, so there's ABD over here. And now I've got to go around the outside over here as well. Is ABC a triangle?
Yes, ma'am.
Yes.
Yes, ma'am. Yes, it is. Okay. So now I have identified the two triangles that I'm going to work in. So either you go left and right at the top and then again at the bottom. If that doesn't work, you go around the outside. Okay, this is now the first thing that we are going to write on the page. All right, we are going to identify the triangles that we are going to prove are similar. So we will say in triangle ABD and triangle ACB or ABC. It doesn't matter. The order here doesn't matter at the top. Okay, it's going to matter soon, but it doesn't matter at the top. Okay, so now I need to prove two things about this triangle. Okay, so if I can prove two angles are equal, then I'll be able to prove that they're similar. So let me read the information. Circles ABCD and ABD intersected A and B respectively. Okay, well, that doesn't tell me much, just that they intersect one another. AC is a tangent to circle ABD, and AD is a tangent to circle ABC, right? So that means that I've got two tangents, right? Now, what I'm going to do is I'm just going to get rid of the highlight, all right, just so that we can see the tangents a little bit more clearly, all right? AC is this line over here. I'm going to highlight it in purple. This is AC. And it is a tangent to the smaller circle at A. All right. Then line AD, I'm going to highlight that in a different color. And I'll tell you what, I'll leave that in purple. Let me highlight this in a different color. I'll highlight this in blue. Here's line AD. And line AD is a tangent to the larger circle, also at A. So matrix, if they tell me that I have got tangents, what is the first thing that I start thinking about? Why are they telling me I've got a tangent?
They're equal to each other.
Are tangents equal to each other? Are all tangents equal to each other? Or is there a special circumstance under which tangents are equal to one another?
They are only equal when they are from the same point, ma'am.
Absolutely, Buhle. They're only equal when they're from the same point. So are these two equal from the same point?
No.
No. Okay. Now, the fact that the lines would be the same length doesn't help us at all, because remember, we are going to be working with angles now to prove similarity. We want to find three angles, three corresponding angles that are going to be equal to one another. So the minute they use the word tangent, all right, what should be popping into your heads is tan chord theorem. Yes? Remember tan chord theorem from grade 11?
Yes.
Okay, so tan chord theorem tells us that the angle between the tangent and a chord is equal to the angle in the alternate segment. All right, so now if I want to have a look at a line that is a chord, right? So in the smaller circle, AB is a chord. The tangent is AC. So the line that, the angle that lies between, actually, hang on a second, that is a chord. So the angle that lies between The tangent and the chord is going to be called angle what in this case? We're talking about the smaller triangle. Angle A1. Okay, so angle A1 is the angle between the tangent. The tangent is AC and the chord is AB, and it's equal to the angle in the alternate segment. All right, so that means that it's equal to D. So the first thing that I know is that angle A1 in triangle ABC is equal to angle D in triangle ABD. And my reason here is tan chord theorem. Okay, so now I've got one angle. Now I need another angle. Okay, well, the only thing they've given me are these tangents. All right, so let me have a look at the other angle that lies between the tangent and the chord. That's going to be angle A2. All right, the tangent is AD, the blue line. The chord is AB, this is in the larger circle, and the angle between the tangent and the chord in orange is equal to the angle in the alternate segment. So that will be equal to C. So that's the second thing that I can write on the page. Okay. C is equal to A2. All right, and this is also because of tan chord theorem. Do you see why grade 11 was so important? Okay, because without that knowledge and understanding, these questions are impossible to try and attempt. All right, so now, if there are two pairs of corresponding angles, right, it means that the remaining angles have to be equal to one another because of angle sum in triangle, or the interior angles of a triangle. So that leaves angle B1 in triangle ABC to be equal to angle B2 in triangle ABD. All right, so this over here, either you can say remaining angles of triangle, or you can say the angles of a triangle sum up to 180 degrees. Okay, but you're not allowed, remember from last week, you are not allowed to say this that I've just highlighted in pink. You're not allowed to say it first. Okay, now hang on a second. I've just been asked a question. Can you explain it again? I'm lost on how we found that angle A1 equals angle D. Okay, it's very difficult to see. Perhaps what I need to do, Kanyesile, is get rid of the highlighting and just show you again. Right, let me just get rid of all of that. Okay. Right. So in this small circle over here, Kanyesile and anybody else who's wondering where this came from, in that small circle over here, this line over here, AB, is a chord. So the angle between the tangent and the chord, here's the tangent, there's the tangent and the chord, the angle between the tangent and the chord, so in other words, A1, is equal to the angle in the alternate segment. Okay, so that's D3. So in other words, if you've come along AC to A1, you've got your finger at A and you've got your finger at B, those are points on the circle. AB is your chord. Now follow both lines to the circle, and that's the angle in the alternate segment. Okay, angle D. All right, Kanyesile, and then it works exactly the same way around for angle A2. It is the angle between tangent AD and chord AB, and it is equal to angle C, the angle in the alternate segment in the larger circle. Timna, what do you want me to repeat? Which part did you miss? If you can just tell me what it is you want me to repeat, I'll repeat it with pleasure. Okay, so on the left here, this is where we've got triangle ABC. So if I write here triangle ACB, is similar to. Now the order is very, 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 I cannot stress this enough how important the order is here, okay? The angles have to match and the sides have to correspond. So if I go A, C, B in the one triangle, in the other triangle, angle A1 matched up with angle D. Angle C in triangle ABC matched up with angle A in triangle ABD. And then angle B1 matches up with angle B2. So the order is 100% critical. We mustn't forget to say angle, angle, angle. The part in the circle with your fingers. Okay, so the best way to do circle geometry is to use your fingers. And I know it's difficult because we're doing this remotely, but the idea is once you have identified the tangent and the chord, put your fingers on the circle where the chord is. So the chord is at A and at B. And now you're going to follow the lines from A and B to D. That's the angle in the alternate segment. Okay, and then it would be the same thing with the larger circle. Angle A2 is the angle between the tangent AB, AD, and the chord AB. All right, so now we've got our fingers on A and B again. And now we're going to trace to the circle to C. Okay, so the angle in the alternate segment is equal to the angle between the tangent and the chord. I hope that helps. Pleasure. It's difficult, Timna, when you're trying to do this remotely, but when you've got this in front of you, you must try and use your fingers. It really does make a big difference. Okay, now, why did I make such a massive big deal about getting the order here that I'm highlighting in green? Why is it so important that we get that correct? We have to get it correct so that the sides that are equal to, the sides that are corresponding do end up corresponding to one another, and that the angles that are equal, right? This bit of information over here, you will never, ever, ever be able to prove it if your order in the green over here is wrong. Okay, so you absolutely 100%, when you write this line over here, I'll highlight it in yellow again. When you write this line over here, you have to make sure that your order is perfect. Slow down. Okay, otherwise you are never going to be able to prove what they've asked you to. Okay. All right, so now that we've done this, we need to write the sides that are in proportion, because that's what they're asking us to prove. They're asking us to prove a proportion. Okay, so this is how we do it. Okay, let's get the pink pen. Okay, so AC, the first two letters over here, that means side AC. So side AC in triangle ACB corresponds with which side in the other triangle, Matrix?
DA.
Good, well done, Tobile, very nice. Okay, and side CB in triangle ACB corresponds with which side in triangle DAB?
AB.
AB, good. So can you see, Matrix, the first two letters over the first two letters, the second two letters over the second two letters, first and last over first and last. Okay, so because these triangles are similar to one another, their corresponding sides are in the same proportion. Okay, and that is our reason. Corresponding sides of similar triangles are in proportion, and we have to write that as well. Now, yes, Adamza, go for it.
What's this? CB over AB, isn't it CB over BD?
Are you talking about the middle one?
Yes.
Okay, but CB are the last two letters in this triangle, so it has to be over AB, the last two letters in this triangle.
I mean, like CB. Wait, it's like with AC is over AD, right? So it's going to be equal to CB over BD, if I'm not mistaken, or is there something?
No, unfortunately, that isn't correct. Okay, so if I have got my order correct over here, which I suspect I do, I do make mistakes, but I don't think I've made a mistake here. All right, then it's going to be AC over DA equals CB over AB equals AB over DB. Okay, now we can actually test that, Anza. We can test that, right? Because remember, sides are corresponding when? What's the deal? How do I know if sides are corresponding? What are corresponding sides? What do they have to have?
They are equal.
No, they're not equal. That's the whole thing. Okay, so with similar triangles, okay, the sides are not equal. All right, they are in proportion to one another, but they're not equal. All right. Parallel lines? No, Cassandra. Unfortunately, there's no parallel lines here. Corresponding sides are opposite angles of the same size. Okay, I did try and stress that last week when we were speaking about it, but I'll stress it again. Okay, I'm going to write it over here for you. Okay, so corresponding, come on, pen, corresponding angles, corresponding sides are opposite angles of the same size. Okay, so we say that sides correspond when they're opposite angles that are equal to one another, right? So the reason that side AC and DA correspond with one another, here's AC, all right? Here's DA, all right? They correspond with one another because B1 and B2 are equal. New color. CB and AB are corresponding. So there's CB, here's AB. Okay, they are opposite angles that are the same size. Remember, okay, angle A1, which is opposite side CB, is equal to angle D, which is opposite side AB. All right, and then the last one here, let's do this in a light pink so that we can see what's going on. AB and DB correspond. Okay, so BD is over here and AB is this side over there. Oopsie. Okay, they correspond because angle A2 opposite BD is opposite angle C. And remember, angle A2 and angle C are equal to one another. We've got it up here. Okay, so I know that I've got my things in the right order. I can actually go and check and say, well, are AC and DA opposite angles that are equal? Is CB over AB, are they opposite angles that are equal? Is AB over DB, are they opposite angles that are equal? And if I've done that, then I know that I'm 100% correct. But if you are just very, very careful in the way in which you write the line with the orange star, you will get this correct, okay, your corresponding sides in proportion. Now what you've got to do is go back and figure out what you need to answer your question, all right? So can you see here, here's a BC. So now we want to find a BC in our answer. There it is. Then we need an AC. Okay, there's an AC over there. So now we need an AC in our answer as well. Well, there's an AC over here. Then we need an AB. All right. Here's an AB. All right, there's a second AB over there, but we can't use that one. Oh, sorry, I'm talking nonsense. That is the one we're going to use. And the reason that we're going to use it, sorry, no, I'm talking nonsense. That was correct. Okay, so we are going to use that AB because the other letters that we want are AD over here. Now, If we hadn't got the line with the orange star next to it in the correct order, it would not have been possible for us to do what we've just done over here. All right, there's our answer. All right. All they've done is that they've just moved things around. Okay, so in other words, we can write down AC over DA equals CB over AB. Now we just need to manipulate this so that it looks identical to our question. All right, here we've got BC in the numerator and we've got AC underneath. So that means that we need to interchange AC with AB. So I'm going to keep BC at the top, or CB, that's this one over here. I'm going to interchange these two. So I'm going to put that over AC is going to be equal to AB. So remember they changed places. So that's why this one is now in the numerator over AD, that one stays behind in the denominator. Okay, why is it okay for me to interchange these two? It goes back to what we were discussing last week. If I have 1 over 2 equals 5 over 10, I can interchange 1 and 10, and my statement is still true, okay? Because 10 over 2 is still 5 over 1. That's why I'm allowed to do what I've done on the right-hand side. Okay. All right, so now you're all very, very quiet, which is either a good or a bad thing. How are you feeling? Do you want to pop something in the chat? Do you want to unmute your mic?
If you guys can give us like a out of 10, how are you feeling about this question? Like 1 being like, I'm completely lost, and 10 being, I absolutely get it. Cassandra, thank you for that 10 out of 10.
So
I'm glad
nice.
it's making sense. And I'm seeing
And
a
Tabile
9,
says 9.
10, and 8. Oh, and Jamie says 11. I like that. Oh, awesome.
Me too. 1,000. Oh, where to? Awesome. Awesome, awesome.
Oh, this is awesome, guys. Yeah. And
Be
those of you
completely
who are like below an 8, I know it's kind of difficult to see at the moment, but it really does take practice, guys. So
it does.
Keep practicing. And if you can, come back to us with your questions on this section if you'd like, so we can help you a bit more where we can. Remember, you just need to be here a couple of minutes before, so we can help you guys out.
Well, thanks for all the responses, guys. That's really awesome to see everybody popping something into the chat box. Okay, so let's finish this question off. Thank you so much for your responses. Okay, it really is nice to know how you're feeling and where you're at. Okay, and please do interrupt me and stop me and ask questions. I've really got no problem with that at all. Now we need to do the second part of the question. So what I'm going to have to do here, Matrix, is I'm just going to have to rub all of this out so that I've got space on the side here to write. Okay, so can you see how long our answer to A actually was? It's all of this here on the right-hand side. This is the whole of A. So first we had to find which triangles we were working in. Then we had to prove they were similar. Then we had to be careful about how we wrote the order of the letters of the triangle. Then we had to write that the corresponding sides were in proportion. And then once we'd done that, we still had to rearrange or manipulate our expression so that it looked like what we wanted to. That's a lot. Okay, so that's 5 things that you have to do all by yourself in order to answer one of these questions. So these are challenging, okay? But I promise, just like Coco said, the more you do it, the easier it becomes. Okay, so yeah, we encourage you to practice this as much as you possibly can. Now, in this bit over here, in part B, where it says AB squared equals BC times BD, you've actually got the answer to this already, you just didn't know it, okay? What does AB squared mean, Matrix?
Isn't the Pythagoras? No.
It could be. It could be. Well, we don't have any right angled triangles.
AB times AD.
Ah, who said that? Label.
Yes, ma'am.
Good. I love it. Okay. So AB squared means AB times AB. Right? Now, where could this possibly come from?
It'll come from where you selected the corresponding sides of the triangles that we proved similar.
Absolutely. And that's why I'm just busy rubbing the highlight out so that I can, whoopsie, there, I got rid of the A there. I'll just put it back. Absolutely. Brilliant answer. It comes from this that I'm drawing the pink box around. Okay, so can you see how critical the order of the letters are? Because the first question getting it right depends on it, and the second question getting it right depends on it. Okay, so you absolutely, when you do this line with the orange star that's highlighted in yellow, make sure your order is perfect. All right. Again, AB squared, as you rightly told me, means AB times AB. So let's go and find the ABs. There's an AB and there's another AB. So I can get AB squared because I can cross multiply. And look, here's BC or CB. So that's this bit over here. And BD or DB is that bit over there. Okay, so this is what they want. All right, so I'm just going to change the order of the letters. I'm going to write, instead of CB, I'm going to write BC over AB equals AB over, and I'm going to change the order of the letters over here, and I'm going to write BD. And now, instead of just cross multiplying once, I'm going to cross multiply twice. Okay, so when I cross multiply AB and AB, that is where I get AB squared from. And then I'm going to cross multiply the other two, that equals BC over BD. Here we can just put proved above. We don't have to rewrite the reason. Okay, Matrix, can you see how? All right, Kanisile, excellent question. All right, Kanisile asked, where do you get the marks for something like this? Okay, so Kanisile, in geometry, you get marked according to statement and reason marks. Okay, so I'm just going to move this over a little bit. I will move it back now. Okay, so a question like this, there would probably be a statement reason mark on that line, a statement reason mark on that line, and then there would probably be a mark on this line over here, provided you had proved it. Okay, so if it was proved, you would get this mark. All right, then there would have to be another mark over here for you writing the corresponding sides that were in proportion, and there would not be a mark on the answer because that was given to you. There could also be a mark over here. All right, so you're probably looking at about 4 or 5 marks. It's quite a lot, isn't it? Right. In the next question, it would be simply a matter of showing that and then showing that you had cross multiplied. Okay, so B wouldn't be out of nearly as many marks. Okay, Kanyesile, good question. I'm glad you asked. It is important for us to know how things are going to be marked. Okay, are there any other questions before we have a look at the traffic light?
Got one in the chat quick. Cassandra says, ma'am, on the orange star, can I say ABC is equal to BDA? Would that make sense?
Okay, let me just write that down, Cassandra. Okay, so Cassandra says, can you say ABC, so triangle ABC, similar to triangle BDA? Okay, let me just have a look, Cassandra, and then I'll be able to answer your question. ABC.
DBA, she says.
So DBA.
Yeah.
Okay, yes, you would be able to do that, Cassandra. Yes, not a problem. Okay, because angle A in the one triangle matches up with angle D in the other. Angle B in the one matches with angle B in the other. And angle C and angle A match up with one another. So yes, absolutely. Nothing wrong with that at all. Okay, you would get exactly the same proportions that I've got, the one that I've drawn the little pink box around. It would just be in a different order. Okay, but it would be the exact same thing. Okay, so nothing wrong with that. As long as you have got the angles that are equal to one another and the sides that are corresponding, it doesn't matter about how you then rearrange it. Okay. Is there another question? Okay, cool. Thanks, Coco, for sorting that out. Any other questions you guys want to ask us before we move on? Okay, I'll take that as. Sorry?
I'd
Go for
like
it.
to, yeah, I'd like to know the first things that we did there. Where you said that the angles between angles and whatnot, they correspond to each other. And the alternate angle and stuff like that. I didn't understand that and how we got to actually proving Tan-Card theorem with both those triangles. At the top, the first question.
Oh, you mean that you didn't understand how I knew that A1 and D were equal and how C and A2 were equal to one another? Okay. What you would need to do, all right, in order to be able to understand that, no, Kanyasile, you don't have to put a reason for B. You can just say proved above, all right? You need to know your grade 11 geometry really, really well, all right? So knowing and understanding Tan-Card theorem is critical to you being able to answer this question, right? What makes this complex is the fact that these two angles intersect one another, and it's not very easy to see which is the angle between the tangent and the chord, right? So in this particular question, right, if you consider that this circle over here is the big circle or the bigger circle of the two, right, the line that's the tangent to it is this one over here, AD, okay, which means that the angle between the tangent and the chord is going to be this angle over here, okay? Here's the tangent, AD. Here's the chord, AB. Okay, this is the angle between the tangent and the chord. Okay, and it's going to be equal to the angle in the alternate segment.
And now I do understand what you're saying right now.
Do you understand what I'm getting at? And then I was doing exactly the same thing, but in the other circle, all right? So in this circle that I'm now highlighting in yellow, there's the circle, but here's the tangent. Okay, so now the angle between the tangent and the chord is going to be this angle over here. Okay, and it's going to be equal to the angle in the alternate segment. That's going to be angle D. That's where it came from. Okay. Sometimes these things are a little bit hard to see, but they are in fact there. Okay. It's a pleasure, Neo, no problem. All right, so let's go and have a look at the traffic light. Now, you definitely do not have to do two of these. Let's just try and do one. I don't want to bombard you. Maybe what's better, if we just focus on one, let's rather do number one rather than number two, because number one is a little bit easier. Okay, so they've told us that ABCD is a cyclic quad, and they've told us that AB and DC produced meet at E. Prove that AE over CE equals AD over BC. Right, so now, just like the question before, sorry, going back to number 3, will I be wrong if I say B1? No, that's perfect. Chuarelo, that's perfect, 100%. Okay, third angle of triangle, remaining angles of triangle, angle sum in triangle, interior angles of triangle, that's perfect. Right, so the first thing that I need to do is what? What was step number? Remember, there were 5 things we had to do to answer this question. So what was step number 1?
Prove similarity.
Identify the triangles.
Identify the triangles. Okay, so how do we identify the triangles, Matrix?
You either go from right to left, or the other way around.
Okay, so you either go left to right, and if that doesn't work, then you go around the outside. So now you say, is AED a triangle?
Yes.
Yes. Good. Is BCE a triangle?
Yes.
Yes.
Yes, it is.
Okay, nice. So that worked out easily for us this time. All right. So that is the first thing that we write on the page, not this, not what I've highlighted, well, not highlighted, what I've drawn a pink box around. Cannot write that first. All right. So in triangle, ADE and triangle BCE. Now I've got to find 3 angles, or actually I've got to find 2. The third will always be equal to one another because of remaining angles of the triangle. So now I've got to find that the only information they've given me, matrix, is that ABCD is a cyclic quad. What do you know about cyclic quads?
Exterior angles are equal to the alternate interior angle.
Okay, Lebo, that's great. So in other words, angle C2 over here is an exterior angle of the cyclic quad. It is equal to the opposite interior angle. So it will be equal to A. All right. Similarly, all right, angle B2, which is also an exterior angle of the cyclic quad because side AB has been produced to E, it will be equal to angle
D.
Absolutely. What can we say about angle E, matrix?
That is a common angle.
It's a common angle. Okay, Lebo, that's great. It's a common angle. It means it is shared. It is in both. All right, so now we can start off. All right, so point number 1. Angle C2 equals angle
A.
A. Lovely. Okay, and our reason? Exterior angle of cyclic. And I'm just going to move this over just a little bit. Okay, point number 2. B2 is equal to
Angle
D.
D.
Okay, same thing. Okay, also because of exterior angle of cyclic quad. These 2 reasons are not always going to necessarily be the same thing. Okay, it just depends on the information that's been given. All right. And now we can conclude angle E is common. Okay, so there's our 3 angles. Okay, therefore, remember this is the most important line we write. Okay, so I'm not going to say it. I want you guys to tell me what to write here.
Triangle CBE is similar to triangle ADE. Angle, angle, angle.
Okay, can you see that? Say that again, please. Triangle?
Triangle CBE is similar to
Yes.
is similar to triangle ADE. Reason being angle, angle, angle.
Lovely, Kanisile. What do the rest of you think of what Kanisile said here? Is she right?
Yes, ma'am.
She
Yes,
is,
ma'am.
isn't she?
Yes.
Thanks, Amanda. Yeah, good job, Kanisile. Okay, excellent. Well done. All right, now, Tundle Wetu, I've never seen cyclic quad abbreviated to CQ. If I was you, I'd rather just write cyclic quad. You know, they do sometimes, and you know what the problem is as well, is that sometimes they're a little bit stricter, and then other years they're a little bit less strict, and then they get stricter again, and then they get less strict. So rather don't leave yourself open to any misunderstanding. Rather, just for the sake of writing another 5 letters, just rather write cyclic quad. Okay, Tundle, where to? Dalen, Miss for angle E, can you also say it is given? No, Dalen, something that is given is something that comes with the question. So like here, A, B, C, D is a cyclic quad. That's given. Okay, but E is not, the fact that E is common is not something that's given in this situation, no. Okay. Candy, pleasure, Dalen. Candy, what's your question?
Candy, please check your mic settings because your mic hasn't been switched on. So you might need to check your mic settings so you can actually speak to us. Or if that's going to take time, maybe you can just type it in the chat quickly while you sort that out.
Okay, all right. So now the $1 million question matrix. Which are the corresponding sides? Okay, what should I write here?
CD over AD. BE over DE.
And AB over DC.
CE over AE
is right. BE over DE is right. But the last thing, just say that again, please.
CE over AE.
It's going to be CE, first and last, over first and last. Okay, so what I've done here, matrix, is I've written the first 2 over the first 2. That's this one. Okay. Then the second 2 letters over the second 2 letters. Right. So now BE over DE. BE over DE. Okay. And then first and last. So in this case, CE in the first triangle over first and last in the second one over AE. Does that make sense to everybody?
Yes.
Okay.
Yes, ma'am.
All right. And then what's our reason here, matrix?
Corresponding sides.
That's it. Corresponding sides in proportion. Good. Corresponding sides in proportion. Lovely. Can you see? Look how quickly we did this one. All right. So we spent a little bit of time. Oh, Jamie, you want to see the second question? Sure, Jamie, you're going to try that one. Go for it. All right, if you can do it on your own, then all the better for you. All right, guys, we are nearly there. Okay, so now again, go back. All right, put a circle around it, highlight it. There's AE. Now we're looking for AE here. Oh, there it is over there. Okay, then we want CE over here. Let's find a CE. Oh, there it is over there. Then we want an AD. Highlight that over there. AD, there's AD over there. BC over here. BC, there's CB. Okay, we've got it. All right, so now all we need to do is write things in the same order that they were given to us. Okay, so now we can conclude that AE over CE is equal to AD over BC. Okay, and remember the reason why this is true is because if I have 1 over 2 equals 5 over 10, my faithful, trusted numbers, if I write 2 over 1 equals 10 over 5, all good. Okay, that's why I can say that. Okay, matrix. Pleasure. Okay, so there's 10 minutes left. Let's see what you guys can do with question number 2 on your own. A little bit more difficult, but let's see if you can do this one quickly, and then we'll try and wrap it up in the last few minutes. Okay, matrix?
Yes, ma'am.
Okay.
Ma'am.
Okay. Angle D, Kanyasile, is all the way down here. Here's angle D. Okay, so I've drawn it in orange for you. No problem, Kanyasile. Okay, I'll do this because we don't have much time left. Okay, so Kanyasile, did you try left and right? Okay, so A, B, D. A, B, D. Can you see A, B, D is not a triangle? Okay, because B, D is not joined. Okay, so left and right is not working in this case. So abandon that and go around the outside. Okay, is ABE a triangle? ABE. ABE. Yes, it is.
Yes, ma'am.
Yes, absolutely. Good. Okay, so ABE is a triangle. I'll try and sort of highlight it here for you in pink very carefully. Okay. And is ADC a triangle? ADC?
Yes, ma'am.
Sure is.
Yes,
Good,
ma'am.
Matrix. Well done. Okay, and it's over here. Okay, so there's your two triangles. Can you see how your highlighter is your best friend? It really helps things to pop out. Okay, so now we know in which triangles we're working. Okay, can you see there?
Ma'am, what if you wrote triangle?
And a way to ask again, what if you wrote triangle?
Tanvuleta, we can't quite hear you anymore. Could you maybe mute and unmute again? Oh, there we go.
Ma'am, what if you wrote triangle ACD instead of triangle
ACD?
That's okay. You can write triangle ACD. You can do that. What you've got to make sure is that when you write this line, remember this bit over here. That's got to be in the right order. If it's not in the right order here, it's not the end of the world. Okay, but it's got to be in the right order down at the bottom.
Okay, ma'am. Thank you, ma'am.
Okay, no problem. Okay, we've got 5 minutes left. I'm going to start going through this in about 2 minutes time so that we finish on time.
Ma'am, I have a question.
Go for it, Brolo.
Ma'am, why didn't you use triangle AEC or triangle ABE?
Okay, I am using triangle ABE. That's the one that I've highlighted in pink. Okay,
Yeah,
but I'm not using triangle AEC because the sides that I'm working with are not in this proportion that I'm given here. All right, so do you see an AE here? No. Do you see an EC here? No. Do you see an AC here? No. Okay, so none of the sides of triangle AEC are given in this particular question. All right, so that's why I'm not going to work in that one. And that's where this method of looking across first or then around the outside works.
Okay, ma'am. Thank you, ma'am.
Okay, no problem. All right, now my apologies for interrupting, but we've got 3 minutes left and we need to finish on time. Okay, angle A1 equals angle A2. So we've identified the triangles. We did that, Kanyisile, when I spoke to Kanyisile. A1 equals A2, Y matrix. Because it's
given.
It was given, quite right. Exactly. All right. What does C1 plus C2 equal?
90 degrees.
90 degrees. Excellent. Who said that?
Me, ma'am.
Oh, well done, Lebo. Nice.
You,
good. Okay. Why, Lebo?
Angles in a semicircle.
Hey, too clever. Angle in a semicircle. Excellent, Lebo. Okay. So very important here, guys, they used the word diameter. They told us that AD was the diameter of circle ABDC. So that means that C is 90. Okay, C1 plus C2 is 90. Okay, so now we've got angle C1 and C2 is 90, angle E1 is 90. So that means, matrix, that C1 plus C2 has to be equal to angle E1. Okay, and then our remaining angles in this particular case, it's going to be angle B
and D.
And D. And now we've got a choice. Either we can say angle sum and triangle, okay, or what other reason could I use, matrix?
Angles in the same segment.
Excellent. Angles in same segment. Beautiful. Okay, nice. Nice, nice, nice. Okay, now for the important part. Oh, we gotta hurry. We got 1 minute left. Okay. So, triangle ACB is similar ACB. What am I talking about? That's not true. Okay, let's go back to this. Triangle ABE is going to be similar to triangle. A comes first, then D comes next. Okay, and then the last one over here would be C. Okay, matrix, angle, angle, angle. Nearly there. Let's just finish this off. Okay, so that means that AB over AD, first and last over first and last, second two over second two, first and last over first and last. because corresponding sides are in proportion. Okay, and now they wanted us to do AB over BE. AB over BE is equal to AD over DC. There we go. All right, so now what they're doing here, AB over BE, they are comparing the numerators. Okay, so AB over BE is the same as AD over DC. Now they're comparing the denominators, AD over DC. Okay, so if I have 1 over 2 is 5 over 10, I can say that 1 over 5 is 2 over 10. That's what I've done. Right, and that's why it's okay. All right. Unfortunately, we're out of time.
Lee, I'm wondering if there isn't a chance you could scroll up, and any of you guys who still want to have a look at this question again, maybe you can take a quick screenshot. I know there's like colors everywhere, but if you'd like to take a screenshot so you can go and examine it again and kind of see where Lee was coming from, it would help you a lot to follow the process that she's worked through here. Okay, but unfortunately, that's all the time we have for today, guys. Thank you so much for joining us. Remember, we have a quiz on Thursday evening. I unfortunately will not be here. Anya will be with you guys on Thursday. I have a school conference to be at, but I will definitely see you guys again next week, Tuesday.
Lovely.
Right,
thank you, Matrix. I hope you are feeling good
much.
after today's lesson and that it's a little bit clearer for you. Okay, and we'll see you again on Thursday. Bye, everyone.
Bye.
Pleasure.
Bye.
Pleasure. Bye.
Thank you, ma'am.
Greatest pleasure.